Welcome back. We are still in level 2 of Amazing Earth. Let's review our big question, and that is, how do Earth's resources change? We've seen how they have changed slowly over time through erosion, weathering, deposition, and through continental drift. Now we're going to start learning about how they change more quickly over time. Before we do that, let's review our key point, which is Earth's surface is constantly changing. These changes occur either slowly through weathering, erosion, and deposition, or rapidly because of natural disasters like earthquakes and volcanoes. Humans can also change Earth's surface both positively or negatively. By studying Earth's changes in natural resources like minerals, rocks, and soil, humans can determine how to use natural resources to survive and where to build structures used for living. Level 2, Mission 2 is on earthquakes. Our mission objective is to explain how earthquakes quickly change Earth's surface. Our challenge questions that you'll need to be able to answer throughout this mission. What causes earthquakes? So what happens on or beneath Earth's surface to cause earthquakes to happen? These are vocabulary words. How are the focus and epicenter related? How do we measure earthquakes? What tools do we use, and what scale do we use? And what kind of damage do earthquakes cause to Earth's surface? Before getting started, we're going to watch a video on earthquakes. Please give it your attention. It will build some background knowledge and allow you to visually see some things that we're going to talk about in our lesson.
About every 2 years, a major earthquake hits somewhere in the world. 1989, Northern California. 1999, Turkey. More than 8,000 minor earthquakes occur every single day worldwide. These minor quakes may cause little, if any, damage. Most earthquakes occur along plate boundaries. As the plates move, these boundaries are the sites of the most intense earthquake activity on Earth. Earthquakes occur during sudden movements along faults, where there are cracks in the lithosphere. Rocks on either side of the crack move relative to one another. This movement puts strain on the rocks. When the pressure becomes too great, part of the rock breaks off and a huge piece of land shifts. The shaking of the ground that results is an earthquake. The shaking is generally strongest at the place where the rock first breaks. It is called the focus of the earthquake. The point directly above it on the surface is the epicenter. Energy released by the breaking of the rocks radiates from the focus in the form of vibrations, known as seismic waves. Scientists detect and record seismic waves with a special instrument called a seismograph. It has sensors that register even the smallest of ground movements caused by seismic waves and pinpoint the location of an earthquake. The 1989 Northern California earthquake lasted just 7 seconds, but it caused tremendous damage. Scientists can measure an earthquake's magnitude, which is the amount of energy released, using 2 different scales. Most commonly used is the moment magnitude scale, which measures how much energy was released by an earthquake. For each whole number you go up, the amount of energy increases about 32-fold. The Richter scale that most of us are familiar with works in the same way, but it is less precise than moment magnitude. The 1989 California quake had a 7.1 magnitude on the Richter scale and a moment magnitude of 6.9. Its epicenter was near the town of Loma Prieta, about 95 kilometers southeast of San Francisco. Shock waves were felt around the Bay Area for kilometers. The effects of an earthquake depend on several factors, including how far away the epicenter is and the geologic conditions of an area. One of the reasons there was so much damage in San Francisco is that parts of the city were built on soft soil that became saturated with water. When there's tremendous ground shaking, such soils temporarily behave like liquids, causing the structures on top of them to collapse. Earthquakes affect not only land, but also the sea. An earthquake on the ocean floor can set in motion a huge and destructive wave called a tsunami. It can travel at speeds of over 100 kilometers per hour and can reach a height of 30 meters by the time it hits shore. Tsunamis often cause major flooding in coastal areas. Using special equipment, scientists can forecast when and where an earthquake is likely to happen. They monitor the area's near known faults for hints of seismic activity. Scientists look out for tremors too small to be felt or sudden changes in seismic waves. Other scientists are studying how to reduce the damage if an earthquake does strike. Engineers use models to determine how to build earthquake-resistant structures. For small buildings and houses such as these, it can be as simple as reinforcing concrete walls by embedding steel bars in them. Tall structures such as bridges require special construction techniques and materials to make them strong but flexible enough to withstand an earthquake. An earthquake is one of the most powerful geologic events on Earth. Scientists continue to study seismic activity with the hope of providing more accurate forecasts of where and when earthquakes will strike.
Let's talk about the causes of earthquakes. What happens to cause earthquakes? Well, as we know, which we learned last mission, tectonic plates, which are underneath Earth's crust on top of the mantle, kind of like those ice cubes in water, are constantly moving. Sometimes they get stuck, causing stress to build up. Remember, they meet at boundaries, and at those boundaries, if they get stuck, it causes stress, a lot of stress to build up. If one of these plates slips suddenly, they will release a great amount of energy in the form of seismic waves. Meaning a lot of energy is going to be released and a lot of waves that we don't see on Earth's surface. They just travel below Earth's surface. They will be released in a great amount, which will then cause earthquakes to happen. These waves cause the shaking of Earth during an earthquake. So what you're feeling during an earthquake is actually the movement of those seismic waves. Unfortunately, we cannot predict when they will happen. However, we can predict where they will happen sometimes. Or not, we know where they're more likely to occur. So let's talk about some vocabulary. A fault is a break in the Earth's crust where earthquakes happen. The focus is the point beneath Earth's surface where the plates start to slip and causes an earthquake. So the focus is if you're underneath the ground and could see where the earthquake starts, that's where it is. It's the focus, and we'll look at a diagram here in a second. The epicenter is the location on surface directly above the focus. At the epicenter, that's where the most damage occurs because it's right where all the action is happening, right above that focus where the plates start to slip. One of your challenge questions was, how are the focus and epicenter related to each other? Well, the epicenter happens right above the focus. The epicenter happens right above the focus. And the focus is where the plates start to slip underneath Earth's surface. So here we see a diagram of this. Notice how it's along a fault. Two plates have met at that fault, and when one of them started to slip, that is the focus, and then right above the focus is that epicenter. How do we measure earthquakes? Well, we use seismographs to measure earthquakes. Seismographs are connected to Earth's crust to detect and measure the vibrations given off by the earthquake. There you see a diagram or a illustration of a seismograph. Notice how it's attached to the ground, which would then allow it to measure the movement underneath Earth's surface. The Richter scale is a scale that rates an earthquake's magnitude. So this is how we determine how strong or the magnitude of an earthquake. It measures through a seismograph the seismic moment, which is the amount of energy released from an earthquake. The seismic moment is the amount of energy released from an earthquake. And there you'll see the Richter scale. 0 is we cannot feel anything that's 0 or 1. But then all the way down there to 9, that's really catastrophic. We don't see a whole lot of those. We don't even see a whole lot of 7 and 8s, although we do see them every once in a while. You see from the chart that one of the last ones happened in 1906. That's over 100 years ago. Let's talk about earthquake damage. How do earthquakes damage Earth's crust? Well, it can damage buildings, roads, and bridges. Flooding and fires can happen because of broken water pipes or broken gas pipes underground. So those are two pretty catastrophic things. And it can also cause other natural disasters, which we'll talk later, like tsunamis and landslides. So those three different points you need to remember and put into your challenge question answer. What damage does earthquake cause? Well, it damages earth and roads, or it damages buildings and roads and bridges. It can cause flooding, and it can also cause other natural disasters to happen after the earthquake. We're going to look at this illustration here, this interaction. This will show you the difference in magnitude and the damage that an earthquake would cause as the magnitude increases. Notice right now, the magnitude is 0. And because it's 0, nothing is happening. Now the magnitude is 2. And you really still can't tell a whole lot is going on. If I move it up a little bit to right above a 4, notice how you can see it shaking. You could probably feel that if you were living there. But notice there's not a whole lot of damage that's happening to that place. So 4, you can feel, but not a whole lot of damage. Let's move it up to a 5. Here where we start to see some damage. You saw some windows shatter. Move it up to a 6. You're going to even see more damage. Now light posts are falling. Rooftops are falling off. Let's look at this one. A 7. Lots and lots of damage. All the way up to that 9. Gas pipes have broken. So there you can see the damage that earthquakes can cause as magnitude increases. How do we prepare for earthquakes? Well, they're most likely to occur along faults. Here in Indiana, we don't really live along any major faults, so we're not going to have any major earthquakes, although there are some times when you might feel earthquakes happen there, but they're probably not going to be very dramatic. However, if there was to be an earthquake, we would follow a procedure called drop, cover, hold on. And there you can see it in that diagram. First, you would drop underneath something. You would cover yourself with something hard, and then you would hold on to that object as the earth is shaking. Let's summarize what we just learned. Earthquakes occur along faults when two plates that are stuck together suddenly slip, causing a massive vibration that can be felt on Earth's surface. The place underneath where that slip happens is called the focus, and an earthquake is usually strongest at the epicenter, which is right below the right above the focus, sorry. We measure earthquakes using seismographs to detect vibrations given off by an earthquake. And we use the Richter scale to measure the magnitude of an earthquake. And The larger the larger we go, the higher the number on the Richter scale, the more damage, the larger the magnitude. This is now the end of this mission. Make sure that you are ready to answer the challenge questions before moving on to the next mission, where we will talk about volcanoes. If you have any questions, please make sure that you are asking them and getting them answered so that you aren't missing anything as we move forward. I will see you in mission 3 on volcanoes.